In the last video, we went over properties of equality. So in this video, we're going to use those properties of equality to solve equations. Let's go ahead and solve our first equation. So our first equation is going to be 5x squared plus 3 equals 83. Now the first property we're going to utilize is the addition and subtraction properties of equality, specifically the subtraction property of equality. Remember, the subtraction property said that if A equals B, A minus C is equal to B minus C. So if this first side of our equation is A, and the second side is B, we can subtract some value C from the left, and we also have to subtract that value C from the right. So that value we're going to subtract is the 3. We're subtracting the 3 because we want to get this x all by itself. And if you remember PEMDAS, the order of operations, parentheses, exponents, multiplication and division, addition and subtraction, we're going to work almost backwards to try to isolate this x and get it all by itself. So we're going to look at addition and subtraction first. So when we take away that 3 from both sides, 3 minus 3 is just 0, so we're left with 5x squared, and that's going to be equal to 83 minus 3, which is 80. So we're left with 5x squared equals 80. Remember, we're still trying to get this x by itself because we need to figure out what x is equivalent to. What value is represented by this variable x? So the next property we're going to use was the division property of equality. That said that if A was equal to B, then A divided by C equals B divided by C. And remember, C cannot be 0. So if you look, our new term, 5x squared, will be our A in this case, and 80 will be our B. To get the x by itself, we need to divide by something that will leave us with just x squared. So to get rid of this coefficient, this 5, we divide by a 5, because 5 divided by 5 is 1, and 1 times any number is that number or value that the 1 was multiplied by. So 5 divided by a 5 is 1. 1 times x squared, we're left with just x squared on the left side. On the right side, we're left with 80 divided by 5, which is 16. Now, if we remember from Algebra 1, the way to isolate a variable, if it's with an exponent, is to raise it by the reciprocal of the exponent, which will go more in depth in Algebra 2. But for now, remember that if a number is squared, in order to remove that exponent of 2, we simply take the square root, and whatever we do to the left, we're going to do to the right. The square root of x squared and the square root of 16. This will give us just the value of x, because that's squared. We'll cancel out, and we're going to be left with the square root of 16, which we know 4 times 4 is 16, so the square root of 16 is 4. So we've solved our first equation. X is equal to 4. Let's do one more example. Our next equation is going to be 1/3 times the quantity x plus 5 minus 2/3 is equal to 4x. So we're solving for the x. I wrote this equation twice because there's a couple different ways to find out what that x is equal to. So I'm going to show you 2 different ways for the same equation. If you remember, we can use the distributive property to start. So essentially, we can get rid of these parentheses using the distributive property. So 1/3 gets multiplied to the x, and 1/3 gets multiplied to the 5. So we're left with 1/3 x plus 1/3 times 5, which, remember this 5 is like 5 over 1, so 1 times 5 over 3 times 1. So 1/3 times 5 is just 5/3 minus 2/3 equals 4x. Our next step would be to simplify. 5/3 minus 2/3 is the same thing as 3/3. So 1/3 x plus 3/3 equals 4x. Looking at 3/3, we know that 3 divided by 3 is just 1. So let's go ahead and erase that 3/3 and write 1. Now remember, the goal of this is to isolate the x to one side of an equation so you can find out what that value of x is. So let's go ahead and subtract the term 1/3 x from both sides. So if we subtract 1/3 x, this whole quantity, we're going to be left, well, 1/3 x minus the same exact value is going to be 0, so we're left with 1 on the left side, and 4x minus 1/3 x, that's going to leave us with 3 2/3. 3 2/3 is the same thing as 11 over 3. So 4x minus 1/3 x is 11 over 3x. Another way to look at this is if you rewrote 4 with a denominator of 3, 4 is really 12/3, because 12 divided by 3 is 4. So 12/3 x minus 1/3 x is equal to 11/3 x. Our last and final step would be to divide by 11/3 on both sides to get x by itself. So dividing by 11/3, when you're dividing by a fraction, a simpler way to think of it is thinking of it as multiplying by the reciprocal. So when you divide by 11/3, you're really multiplying by 3 over 11. So dividing by 11/3 is the same thing as multiplying by 3 over 11. So flipping that fraction. So 11/3 will cancel each other out because 11/3 divided by 11/3 is 1. So we're left with just x. And 3/11 times 1 is just 3/11 because of the identity property. So x is equal to 3/11. Let's look at another way to solve this equation. Remember in the first example I said to remember PEMDAS. And I'll write this so we remember it. PEMDAS, where addition and subtraction and multiplication and division occur essentially within the same steps. So let's reverse PEMDAS to solve this. So first we're going to start with addition and subtraction. We need to isolate this x. So let's start by adding 2/3 to both sides. Then we're going to be left with 1/3 x plus 5 is equal to 4x plus 2/3. Right here we already have something completely different than what we did over here, because we started over here by expanding this simplified form. We used the distributive property to expand this out. And then we did our addition and subtraction and then moved on to our division. Here, we're starting with the addition and subtraction, so we're not expanding anything out. We're leaving it in a simplified form. So now our next step would be multiplication and division if we could. So we divide the left-hand side by 1/3, and we divide the right-hand side by 1/3 as well. This will leave x plus 5 all by itself. So we do not require the parentheses anymore once it's all by itself. Over here, however, we're going to have 4x plus 2/3, all of that divided by 1/3. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So really, we could say this whole term, as opposed to being divided by 1/3, is multiplied by 3/1, which 3/1 is really the number 3. So we have 4x plus 2/3 multiplied by 3. So now we're going to have to use the distributive property again, but first, let's get x all by itself on the left-hand side. So subtract by 5 from both sides. So we have x is equal to 3 times 4x plus 2/3, and that minus 5. But we have a problem. There's still this x on the right-hand side. So let's expand this out to try to get the x within a single term. 3 times 4x is 12x. 3 times 2/3 is like 3/1 times 2/3, which would just be 6/3, which 6 divided by 3 is 2, minus the 5. So we have 12x plus 2 minus 5 is a negative 3. Now, let's move this 12x to the other side to get the x's all on one side of the equation. X minus 12x is going to be a negative 11x, and that's equal to a negative 3. So now we just have to divide by negative 11. X is equal to negative divided by a negative is a positive. So x is equal to 3/11. The same answer we got on the left. When we solved the equation on the right, it had a few more steps. So sometimes expanding out in the beginning is more helpful, because you see we didn't do it over here, and we wound up expanding regardless down here to get this x out of the parentheses so we could move it over to the other side with the same x. There are different steps you could have taken to solve this same exact equation. Like, for example, down here, I could have expanded out first, like I mentioned. Instead, I subtracted by 5 and then expanded out. So remember, there's multiple ways to solve an equation to figure out the value of the variable you're solving for. And no one way is necessarily the correct way to do it. There are multiple ways to reach the correct solution.